Hello everyone, welcome to week 10 for practical math, real world math applied to finance and economics. We're going to look into the topics of inflation and unemployment and talk about, is there a correlation? So the essential question, is there a correlation between inflation and unemployment? These are kind of big topics in the US and the economy. We're going to dig into this idea and use some math to help understand it. So we're going to talk about inflation and unemployment. We're going to define this thing called a Phillips curve in economics. We're going to use a regression analysis to determine if there's a relationship between unemployment and inflation. We're going to produce some graphs utilizing our Desmos calculator of the two variables on a scatter plot. I'm going to show you how to compute a regression line, let the calculator do all the heavy lifting in the math, but then interpret what it's telling us in terms of how well do these variables relate together. So this is our goal. We're going to really get into some graphing, some linear equations, and understanding what's going on. Take notes. You can pause the video at any time. Use the video as you're working on our week 10 assignments as well as the text that I give you. Let me know if you have any questions or want any help going over anything. All right. How much does it cost today to buy a new car? Maybe you got your eyes on the new 2016 Mustang GT. And it'll cost you about $42,000. It's a pretty slick ride. Perhaps you got a different car, but cars are pretty expensive. Anywhere from $25,000, $30,000 for lower models to, $500,000 depending on what kind of car you want to get. But what's funny, let's take this 2016 Mustang. Today is $42,000. But if we wanted to go to 1986, so 30 years ago, to your dad's Mustang GT, it only cost $14,500. And there it is. Pretty slick ride, right? Looks like an antique, but that was a big deal back then. So things cost more as time goes on. We kind of know this, right? We always laugh about how cheap things were back in the day. The increasing costs over time are due to what we call inflation. Inflation is defined as a rise in the general or average price level of all the goods and services produced in an economy. Over time, things usually tend to cost more, and we want to track, well, how much more does it cost? And that's inflation. We want to keep track of that. So we're going to watch a little short video introducing you to more about inflation, and then we'll come back and go over some math here.
Inflation is a rise in the general or average price level of all the goods and services produced in an economy. We can't measure the prices of all goods and services produced in an economy. That would be impossible. Therefore, we measure what happens to the price of a basket of goods and services that the average person might buy. Then we compare this value to the price of the same basket in previous years. This is how the Consumer Price Index, or CPI, is constructed. The CPI is a measure of the price of a fixed basket of goods and services bought by a typical consumer. Inflation has been with us for a number of years. In some years, the rate of inflation is higher than in others, but prices have shown a consistent tendency to increase rather than decrease over time. When the average price level increases, the buying power of the dollar decreases. Inflation affects different groups of people differently. Some are hurt and some are helped. For the most part, people on fixed incomes like pensions are hurt because their income remains the same, but their buying power decreases. This is why many pensions in recent years have built-in cost of living adjustments. Lenders are hurt by inflation, while borrowers are helped. This is because borrowers pay back money that will buy less than it did when they borrowed it. Lenders get paid back with lower valued money. To protect themselves against this kind of loss, lenders try to estimate what the inflation rate will be over the time of the loan and set interest rates accordingly. Savers are hurt by inflation because their savings are worth less.
All right, now that we have a good understanding of what inflation is, let's look at the issue of unemployment. Unemployment is the number of people 16 years old and up who are without jobs and are actively seeking work. So what does that mean? Let's look at some examples here. So we got David. David is our 29-year-old male. He does not work. He plays video games 8 hours a day and lives in the basement of his parents' home. He has not filled out a job application in 6 months. Is David counted as unemployed? Well, to be unemployed, you are over 16 and you are actively looking for work. He's not filled out a job application in 6 months, so no, he is not considered unemployed. He's happy not being employed. He's just doing his thing. If he was actively sending out resumes, then he would be counted as an unemployed because he's looking for work. All right, let's look at another example here. What about Martha? Martha is 34. She's a stay-at-home mom. She does not work for pay outside of the home. Is Martha counted as unemployed? Well, similar thing. She's working, but she's not actively looking for a paid job outside of the home. So no, Martha is not counted as unemployed either. How about Jennifer? Jennifer is a 19-year-old female. She works part-time at the pizza parlor. Is Jennifer counted as unemployed? Well, she's over 16. She's working part-time, but she's not actively looking for work. She's actually considered employed. So she's employed by the pizza parlor. So no, we do not count her as unemployed either. And you're like, come on, Mr. Close, give us an example of someone who's unemployed. Well, here we go. We got Walter, and he's a 45-year-old male. He is not working, and he submitted his resume to 2 firms this week. Is Walter unemployed? Yes. Mr. Walter is over 16. He's actively looking for work. He does not have a job yet, and he is considered unemployed. So what we're going to do, though, is use math to see if there's some sort of connection or relationship between inflation rates, which we watched a video about, and this idea of the unemployment rate. How many people are looking for jobs that can't get them? So we're going to see, is there a positive relationship? What that means is do variables move in the same direction. As our inflation increases, does the job rate, does the unemployment rate increase? Or is it a negative, an inverse relationship? Does the inflation increase cause unemployment to decrease? We're going to look at that by looking at some data and graphs and looking at these relationships here. So let's take a look. For the years 1964 to 1969, economists made a mathematical model and they wanted to look for relationships. So let's see what we got here. So they plotted all the points. You can see 1961, 62, 63, 64, 65, 66, 67, 68, 69, and they kept track of the unemployment rate. If the unemployment rate changes, how does that affect the inflation rate? And what we see is, right here at this point, that's a high unemployment rate. That's over almost 7% of people are looking for jobs that can't get them. They're unemployed. A lot of people looking for jobs, and the inflation rate is really low. So prices are not increasing. Prices are kind of staying the same year after year, but a lot of people are looking for jobs. But if we go up the curve, things change a little bit. Now we get to 1969. So over that 8-year period, what do we see? Well, less people are unemployed. There's just under 4%. So more people are working now that didn't have jobs before. So in 1969, I think people felt better, like, hey, I can get a job. Whereas in 1961, it was harder to find a job. So more people are working. The unemployment rate is lower, but what's fascinating is the inflation rate is high. The prices of goods and services were increasing a lot from that time. So people would go shopping and be like, man, these eggs, they cost a little bit more than they did a year ago. Or, wow, gasoline has really increased a lot in the last year. So we want to look and see, is this relationship continuing? This would be an example of a negative relationship, because as the unemployment rate decreases, the inflation rate increases. So they're opposite. If I lower one, I increase the other. If I lower the other, it increases the one. So that's what we would call a negative relationship. And we tend to see that by lines or graphs that go downwards. That's also an indicator of a negative relationship. So we got this 5-year period, actually this 8-year period according to this graph, that it looks like it forms a negative relationship. Using the previous graph, economists argued then that, hey, let's call this a Phillips curve. And what we see is if we have more inflation, then things are growing, prices are increasing, policymakers, unemployment will decrease, right? If you want to get reelected, if you want to be seen as a good politician, people want jobs. And if they have jobs, they're happy. And so if you can keep the unemployment rate down, then you're a successful politician. So some would argue then by looking at that graph, we need to raise the inflation. We need to make sure things are growing in terms of prices so that the unemployment rate decreases. We think there's a causal relationship. If I do one, it'll affect the other. What we're going to look at, however, is this actually true? We're going to look at beyond the 60s, we're going to look at the 70s, the 80s, 90s. We're going to look at other decades to see if that relationship is still there and make some informed decisions using our math. So here's the data from the 80s. You guys love the 80s, right? Home to ET and spandex and neon colors. We're going to put these data, so 1980 all the way to 89, you can see the unemployment rate, and you can see the inflation rate, and we're going to graph it and see if there's a solid relationship. Follow along, take notes. I'm going to show you how to use the Desmos calculator and to do some statistical graphing, some measuring of what we call a regression analysis. So I'm going to close that down. I want to keep the graph open though because I need to see all the values. I'm going to have that there. I'm going to open up my Desmos calculator. Okay, so in my Desmos calculator, I need to put in this table of information. I need 1980 to 89. I need a column for the unemployment rate, and I need a column for the inflation rate. And I'm going to graph those. Again, unemployment was our X values. Inflation was our Y values. I'm going to see what's going on. So I need to insert a table. I'm going to come over here. Insert table. And now I need to put in my X values as my unemployment rate. My Y was my inflation rate. So let's bring this up. And the first one was 7.2 and 13.5. Now for the next year, we had 7.6 and 10.4. Okay, here we are. We've got all the points in. You can see a nice little graph. And what we want to do is look for a trend. We're going to do a linear regression on this. And the way to do that is we're going to come up with a line that seems to follow how well the data is fitting a relationship. And then we're going to look at some stuff. So the way to do that, we're going to start a new equation. I'm going to do y1 because I want to relate all the data in y1. So I'm going to type y and a 1. Now I need to make it not an equal sign. I need to pull up on my keyboard, switch to the ABC mode, and I need to use this symbol right here. It's sort of like an equal sign, but this is more approximating. So I want to relate y1 relating to m is my slope, because I'm making a linear one, times x1. So now it's relating the column in x1 plus my y-intercept, b. What do we see? Most of our data is right around here, but we have a couple random spikes way up here, and so it's trying to fit a line through it, but it's getting kind of really skewed. What do we have right here? So this is saying if you want to make a linear regression, y equals mx plus b, your slope m is 0.2, about 0.21 if I round it. My y-intercept b is 4.03 right there. And I'm also given some values of how well does our line fit the data. I get an r value of 0.0858? Well, let me tell you this. If you get an R value of 1, then your data is in a perfect positive relationship. If you get a value for R of -1, it is a perfectly negative relationship. Your points are fitting that line perfectly. If you get an R value of 0, your data is not linear at all. It means it does not fit. There's not much of a relationship. So when I get an R value of 0.0858, and I'm looking at this and not really any of the points seem to fit any sort of a pattern, then I'm going to say, you know what? During the 80s, there's no relationship between employment, unemployment rate, and the inflation rate. In fact, it's all kind of just scattered about. Here we go. The inflation rate was high, but the employment rate was high. Here we go. The inflation rate was low, but the unemployment rate was high. Here the unemployment rate was low, so it got lower, but also the inflation rate was lower. It's just kind of all over there. There's no really linear pattern. So in our analysis using math, we would say there's no pattern. This does not seem to be a relationship between unemployment and inflation. So there you go. That's what the 80s tell us. So our linear regression equation, we had the line of fit was y equals, I think we had a slope of about 0.21x plus about 4. I can't remember the exact value. And the correlation value for R was 0.0858. So what is our analysis? I would say there is no relationship between unemployment rate and inflation. So as good as the 60s were, and it seemed to show a relationship, in the 80s didn't work that way at all. Interesting. All right, so let's look at the 90s. Maybe the 90s are different, right? Here's our unemployment rate. Here's our inflation rate. It looks like 5.6. This kind of increases, then it decreases. Do we see that kind of same relationship here? So I'm going to go ahead and graph these. Let's take a look at the graph. I'm going to graph these ahead of time now that we know how to put it in. I'm going to graph them, and then we can look at our regressional analysis and see what we got here. Okay, here we are. I've got all my data in for the 1990s. We can see there's my values. I put all the x values and the y values into my table. I still have my regression analysis pulled up. And if I look at this one seems to fit a little bit better. I have kind of one point that's kind of way up here that seems off. But in general, as the unemployment rate increases, it seems like my inflation rate increases. Now, if you remember right, so it looks like there's a relationship, but it's opposite. This is a positive relationship. I can see my line is increasing. If you remember the whole Phillips curve from the 60s, it was decreasing, and people thought there was an opposite relationship. So let's look at some values here. So in this case, my slope is 0.43, so it's increasing, it's positive. I have my y-intercept, 0.47. And my R value is 0.43. Well, the last example in the 80s was 0.08, which almost meant like there's no relationship at all. In fact, there's not anything connected. 0.434 would indicate, okay, there's some relationship. It's not very strong. To be strong, you want like 0.8 or 0.9. But there is something. There's a little bit of a relationship between the two, enough to have some mathematical relevance. And we can see that they seem to follow kind of a trend line. If this point was a little higher, and if this point was gone, and if this point was a little higher, then we could say there's a better relationship. All right, let's go back and summarize our results then for the 90s. So in the 90s, what did we see? We had a different equation. Y equals 0.44x plus 0.48. So we had a different slope. My slope was bigger than the 80s. My y-intercept was smaller. My correlation was I didn't write that down. It was 0.4. something, 0.45 something. I have to go back and look at it. But my correlation was much higher. So the analysis is there's a slight relationship, a slight positive relationship according to the 90s. In other words, if you looked at just the 90s, you might think, oh, if I increase inflation, it's going to cause the unemployment rate to also increase. So maybe we don't want inflation. There's a slight relationship there. Not too strong because this is not super high, but it's enough to show some results. Okay, last one. Let's compare the 80s, compare the 90s. Now let's look at the 2000s and see if there's any relationship between unemployment and inflation. So here's the data from the 2000s. I'm going to go put that into my Desmos calculator. And let's again find a linear equation, find the correlation, and see what we can see. All right. Here is my data for the year 2000. It's most recent for us, right? What do we see? Well, we see the opposite. Looks like over this year, the trend is negative. So my graph is decreasing. It's following a trajectory of points that would seem to indicate, in this case, the opposite of the 90s. In the 2000s, the trend seemed to be as the unemployment rate was higher, inflation decreased as well. Or if you have more inflation, then the job rate, the unemployment seemed to change. So like right here, the unemployment was 9.3%. That's a lot of people looking for work because we had negative inflation going on, right? Whereas over here, the unemployment rate was only 4%, so a lot less people looking for jobs, but the inflation rate was higher. So this would seem to strengthen in the 60s their claim that, hey, let's play around with the inflation rate. It has some effect over the unemployment rate, right? The higher the inflation, the less people that are looking for work. Low inflation, yikes, a lot of people looking for work. If I pull up an equation, if I look at my statistical results here, our R value is negative 0.863. That's our strongest relationship rate. So remember when negative 1 is exactly linear, this is pretty close to 1, negative 0.86. That's a strong relationship, stronger than our 0.4, it's stronger than our 0.08. So in the 90s, in the 2000s here, we had a strong relationship between unemployment and the inflation rate. And our equation would be y equals, our value for m was negative, so negative 0.7, let's round it to that. And our y-intercept was 6.4. All right, let's go back and summarize the results that we see here. So in the 2000s, what do we see? We have a linear regression. The equation was y equals negative 0.7x plus 6.4. So out of the 80s, 90s, and 2000s, this was the only one that actually showed a negative relationship. Our correlation was negative 0.863. So our analysis, this is a fairly strong negative relationship. So there we go. We just looked at 3 decades worth of data by making a graph and letting the calculator do some of this work for us. It was able to come up with an equation of a line, and it was able to tell us how well did our line fit the data. 1 or negative 1 is perfect. 0 means there's completely no relationship. So what we're looking for is R close to 1 or is it close to negative 1? And if so, that indicates a strong relationship. In the 2000s, we had a fairly strong negative relationship. So again, our goal was, according to the 60s, according to these economists, they thought a relationship was there between the inflation rate and unemployment, and so we looked at decades after that to see if it was actually true. What did we find? We found out that according to the 80s and 90s, correlation was really weak. And if anything, there might have been a positive relationship, but really you would say, nope, there's no correlation. All those people, all those yahoos in the 60s, they were totally wrong about it. So there's no relationship. So that was counter argument to the Phillips curve data from the 60s. However, if you just focused on the year 2000, there was a stronger relationship, and it was also negative, just like they said in the 60s. So the 2000s would seem to support it, but in general, there's not enough consistent data. It's up, it's down, it's weak, maybe a little strong, it's positive, it's negative. Each decade was really different. There maybe is a tiny bit of correlation, but mathematically, we just made a good case that no, there's not really enough to make major policy decisions based on this relationship. So there you go. We talked a lot about inflation. We talked about unemployment, and we used math to take these variables and try and figure out, is there a strong enough relationship between them to then say, yes, we should make this economic policy. This is the best way to reduce unemployment and help people get jobs. We can't say that with certainty, at least not by just changing the inflation rate. There may be other things going on, but we were able to make a graph, understand the results, the regression line, the correlation coefficient, and use our math to actually explain that there is not a very strong relationship between these two variables. All right, hopefully that was interesting for you. Hopefully you're feeling solid about graphing and solid about interpreting graphs and regression analysis. And I look forward to working with you guys later.